of this website. So I'll be explaining each output. Maybe not all of them, though. The ones I know already, you understand. I'll just explain. Yeah, why we can as well do research on our own. Can give it to AI to help you explain what's going on here. You understand? So for the first one,
Promise.
yes, I can hear you.
Yes.
Yeah.
Okay, so before you go far, I want you to tell us DNS recon, what is used for? What is the purpose? Why are we using DNS recon?
Okay, DNS recon is actually to check the DNS service, like it's like a security check. You understand? So, like what we are having here, after we run this command on the target, it's we checking the security structure. You understand? And what else is available out there, like checking the IP address to see if the IP address is made public, to see if they have what's it called, some security uh, configured, like this DNS security extension. You understand? To see information about the DNS what's it called, structure of the website. You understand? So this actually just gives you information about a website. Let's say you want to do pen test on a website. So just to gather information about our website. You understand? So that's what it is. Is that understood?
Yes.
Is any
Okay,
other
so how to
question?
use it is to do DNS recon dash
Yeah.
D. What is that D for?
Okay. This dash G is like telling you, is like you telling DNS recon that now after dash D that you are putting the target URL. You understand? So it's referring to the target URL, like we can see from here. You see domain, what's it called? Domain, domain. You get that target domain. In fact, it's not even a link like that. It's just the okay. You can just put the name or the URL like this. You get, so that's it. Dash D. Then you put the URL. So if you do it without the D, it won't work. It's not supposed to work. Let's see. You see, so that's it. So first of all, this first output, it says starting enumeration for domain. That is, it's starting to gather information about the domain. And then the second one, performing general enumeration. That it's performing the enumeration, gathering informations about this domain. Yeah. And then it says error, no answer for DNS SEC query for this domain. You understand? So that means there's no answer. That's when DNS Recon asked for this. This is a security configuration, or what will I call it? But this DNS security extension is actually a security is actually a security setup for DNS. You understand? That helps to like protect against DNS spoofing. You understand? So you don't like get redirected or stuff. It's like this DNS SEC uh, security program now is like to confirm. It confirms requests. You understand? Let's say you are browsing a site. You 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 put in, let's say, google.com. You understand? So your computer needs to translate it to IP address to communicate with Google server. But if it happens that there is an attacker in between, maybe through the router you are connected to or something, the attacker finds its way to get into that traffic. The attacker can actually manipulate the domain that that you'll be connected to once you browse a particular website that does not have this security configured. There might be others that can do the work of this particular one. There might be other kind of configurations that can provide that same security. I don't really know. But for this one, now it doesn't have it. You understand? So that is it. It shows that no answer for DNS. That means DNS Recon actually asked if this security uh, module is configured here, and it says no. You understand? There's no answer for it. And then we have this SOA. For this SOA, what is it again? I think authority, something like that. That's what it is. I haven't really gotten the exact explanation of what it is, so I will leave that to us. You understand? So we can go and do our research on that. And then we have a this A is actually A records. I remember maybe they've done some upgrade or something like that. So I remember when we did all of these same websites, there were four like that we did in our uh, assignments. Then it was A record, you understand, and it appeared like that A record. So it's still the same thing. So that this A record actually means that these are the IP addresses for these websites. You understand, and there are different IP addresses here because they are of different servers. You understand, so a website can be hosted on different servers. So it is actually done because sometimes some servers might fail, or to reduce the workload uh, of a server. You understand? So you just have to distribute the load to different servers. You understand? Or in case an attacker attacks one, the website won't just be down and not bringing any response. So there can be others that will be working. You understand, to keep the server, the website running. You understand? Please, do we get that?
Yes, we do. Go ahead, Miss Promise.
All right. Okay. Okay. So and then we also have similar things like that. SROV, which is also service record. You understand? So it's just in one of those stuff there. So we can do our research on this because with different website, you will have different results. You understand? So different, you can scan some websites and your output will even be like more than what this screen can occupy in one look. You understand? So we can go and do our research on all of that. So this is just to look at the DNS structure of a particular website. That's what this tool is for, just to gather information. You understand? To know that okay, kind of this is the kind of security that this website has, or this is the DNS record or structure of the website. That's just what it is. So, and then let's move to ClockQuest. Yeah. So, ClockQuest is actually is actually a tool that can be used to find IP addresses. ClockQuest is a tool that can be used to find IP addresses of websites, you understand, of subdomains, you understand, and a website. So that's what ClockQuest is used for. And even when those IP addresses are hidden behind a cloud or whatever security service, you can still be able to see those IP addresses. You understand? So you know that if you want to uh, exploit any websites or do any penetration testing, your computer actually needs the IP address to help it communicate with the uh, website and the server. So you need to have the IP addresses. So that's what ClockQuest does. So in ClockQuest,
Promise, are you there? Nandi, welcome. Oh. Am I
Thank
audible,
you.
please?
Thank you.
Promise, we can't hear you. Or is it only me?
I think it's promise network.
How are we going to do this country like this now?
Good evening, everybody. Good evening.
Good
Sorry for
evening,
being late. Yeah, I joined not too long ago, so I was having serious issue with my network. I couldn't even come on WhatsApp or anything. Just managed to start going a little right now. So I think Promises network is also having issue because he's not online anymore.
I'm telling you. I've tried to reach out to you. I even call your number. I think one of your
Even
staff.
nothing was going. Okay, yeah. My staff is with my phone. I came home to anchor this program, but network has just been messing up. Couldn't even use WhatsApp. Couldn't use anything. So I don't know if it's strong enough for video. But I was hearing everything Promise was saying until he logged out. Maybe we
Try.
wait a little while, see if he will come back and finish up.
Just give me a few minutes. Let me reach out to him. I'll come back here. If you are to start your own presentation, we'll know.
Okay.
Press 0 to leave a voice message after the beep. Hold button apply.
Okay, so I'm not able to reach out to him. Nnamdi, please, can you try? Let's see if your presentation will be able to.
All right. We already introduced SS yesterday, so it just to show how it's used, then move on to Wireshark and then Darkstart and TCP dump. So I'll share my screen now. Okay. Please let me know when it's visible. Guys, can you see my screen?
Yes, we can see your screen.
Okay. So let's just go to SS. Apologies, I haven't started my Kali. Okay. So like we discussed yesterday, SS is used for analyzing a machine's sockets to look for traffic. And because it analyzes sockets, it's always requiring what's it called? Root privileges. So you run it with sudo ss. Okay, let's see the help page. Okay, so these are the important ones we'll be using. We'll be using numeric. Numeric shows you the numbers of the ports. Like instead of, if you don't use numeric, you will see HTTP. When you use numeric, you will see 80. So it's just numbers, port numbers. Then arrow resolves host names. If you use arrow, it will change IP address to host name, like you see google.com. But when you don't use R, you will see the IP address. Then A is for all the sockets. We'll use A2. We'll use P. P is for processes. All the processes that are using sockets. Processes is more like services. Okay. Then what else? Okay, those are the important ones. Then L, we'll be using L. L is for listening ports. Yeah. Look at it here. It's for ports that are listening. You know, a port you can have a port, but it's not open. It's not listening. So, but when you put L, you will see the ones that are listening, because a port has to be listening on a machine for it to receive services. Okay, so that's about that. Then we'll be using T too. T shows TCP ports. This one. U shows UDP ports. This one. So basically analyzing this machine to see what is going on. So I think I'll start with TCP ports. Okay. Oh, okay, because you know Kali is kind of secure. So you're not going to see much ports open on Kali. If you're using Ubuntu or Debian, you will see way more ports open. But Kali is somehow very secure, and is not used for your normal browsing and stuff. It's more or less an attack machine. So that's why I don't really have much things open. All I can do, all, let me see. Yeah. So I have more things here. Even as okay, you can see this, all these listing are ports that are listening. Let me go to the headings. So wow, this thing is much. Okay. So from here, this is the network ID. This is the state. All this uncon is unconnected. That means it's not in use. You will see some established. These ones that are established are the ones that are in use. You will see some listening. Listening means they are open, they are listening, but they are not yet established. Okay. So this basically analyzes your system and tells you all the services that are running, all the ones that are listening. This is received, something, send. I can't really remember what these things are for, but they're not that important. Then you have the local addresses. These are addresses that are using the ports and the ports that are in use. So these are the port numbers. Like this local address is using 767. This one, network manager, is using 581. So this is where you see all the, you know, there are so many processes that run on the background that you will not know about. MOT always used to tell us that. So with this tool, you can view all of them. SS is not used for network analysis. It only shows you what is going on. Okay. When you see what is going on, then you can analyze it with other tools like Wireshark and Darkstart and TCP dump. So, but in this field, the one you will always use the most is this command TULNP. Yeah, this is it. This shows you TCP ports, UDP ports, listening ports, numeric, and processes. So when I enter this, you're going to see 127.0.0. I have an IP that is using port 4305. Okay, let me see what this process is. I think it's my loopback IP. Yeah, this is the IP. It's the loopback address. So it's just kind of talking to itself. Loopback is the connection mode that a machine uses to talk to itself. So assuming I'm in a session with somebody, let's say I SSH into somebody's machine, I will see it here. Okay. Or let's see if I can open SSH sudo system ctl /SSH. Yeah. So now SSH is running, and then I check this. Yeah. So the same command I ran here is what I just did here again. Now you can see I have another port open. This is port 22 SSH. This is the process. The user is SSH. Okay. Same thing here. I have another SSH open here. This address is for IPv4. Why this one is for IPv6? It's basically the same service, but different types of connection. So if you're on my network and you know my username and you have my password, you can SSH into my machine right now because my SSH is open. My port, SSH port 22 is open and it is listening. You can see the state listening. So this is basically how you use SS. You can use it to analyze systems. The particular system you are on. If you want to use it to analyze another system that you're not on, you will need SSH permission to get into that system. Then you run it on that system. That's the only two ways. Either you physically carry the system and run it on it, or you SSH into another system and then run it on that system. It is not like Nmap that you can use across network. Yeah, you have to be on that particular network. You have to be on that particular system. So that is it about SS. Now let's see you've seen ports that are listening or ports that are established. And you now want to know what they are talking about. You want to see what they're actually doing, not just that you're seeing that they are listening, that they are established. You have to capture the packets. Now, packet capture is just like you capturing a traffic. You will be able to see what the traffic is and what they are doing. Okay, so Wireshark gives you more information and you'll be able to analyze it. So with that, we'll be moving over to Wireshark. Let me just open a new tab.
Sorry, Nnamdi, before you move to Wireshark.
Okay, go on.
This SSH, I just want to understand the difference. What about you're talking about, trying to get an access into another system through SSH, through SS, through this SS, right? But what about
no, to get into, hold on, you're missing it up. To get into another system, you use SSH service. SSH is secure shell port 22.
Yes.
There are two different things. But SS is a tool for analyzing a system's socket.
All right.
Now let's see how it works. Let's say you are in the field and you want to examine someone's network. The first tool you are going to use is SS. Let's say it's a big office now and they have up to 10 different systems for you to examine. You can be going physically to each system and using SS on that system.
Okay.
Or you request to be made a user, then you stay with one system and SSH into another and run it in that one. Yeah.
Okay.
Those are the only two ways. You can't just connect across a network. No. You have to get into that system with SSH to be able to use it, or you take the system physically and run it on it.
Okay.
You know, when we learned Mmap, you can literally use your system and analyze another one without needing to SSH into that one with Mmap. But SS doesn't work like that. It's either you SSH into the other system or you carry the system physically and run it on it. Like as I am here now.
What if I use another? What if I didn't use SSH to access the system? Maybe I use FTP or I just act through the system.
That means
exactly.
Okay. All right. If you use FTP, it means you're not getting the right way. You are using an exploit. That is a backdoor or something. So you've already discovered an exploit. FTP is not meant for command execution. It is meant for file transfer. But if there is an exploit, you can get in with FTP.
Okay.
Are you getting it now? But in an event where there is no exploit, you cannot get into someone's system with FTP. The reason why we are doing it is because there is an exploit. That exploit is creating the backdoor. It's not that FTP was designed to, execute command execution. No. Do you get it?
Yes, I get you now clearly.
Yeah.
Thank you.
Ordinarily, if you want to analyze a company's network, you are not just going to know whether there is backdoor or not. So you will not be getting in with FTP. You will get in with SSH, and they will give you their usernames and their passwords.
Yes, to get in.
Except if they have another service that has a backdoor. Now you can get in. Okay, are we on the same page?
Yeah.
Because while we are learning, we have to be learning as if we're in the field. So what is applicable and what is not? You will rarely see an FTP service that has a backdoor and people are using it and they don't know. It means their IT department is not doing a good job. Okay. Are we there?
Yes, Namdi. Go ahead.
All right. Any other question before we move over to Wireshark? You can practice SS on your own. If you have Ubuntu or Debian, it's even better. You will see a lot of traffic, but you won't be able to know what is actually going on. You will just see established and the ones that are listening. That's all. If you now want to capture and analyze, then you move over to Wireshark. So let's get there. So here is Wireshark. These are the things you need to know about. Let me maximize this. The things you need to know about Wireshark. This tool is basically used for capturing network. Okay. Now, you capture on an interface. This is one interface, ETO. This ETO is my what is it called? My internet, my router. Okay, it's connected to this interface. Then N is a accumulation of all of them. Loopback is the one the machine is using to talk to itself. We already discussed that. That's that 127 point something that we saw. So if I want to capture network belonging to that interface, I will select this one. Now Docker is what VM uses. If you know about virtualization, virtual machines use containers. The containers contain Dockers. So this is basically what the virtual machine uses to talk to itself. Then you have Bluetooth. If you have someone connecting to you through Bluetooth, you can still capture their traffic. You just select this one. So, but for the case of these studies, we'll be focusing on ETO. Now you also have filters here. Let's say you don't want to capture the entire traffic. You can select filters. You can select only IPv4. You can select only IPv6. You can select only TCP. You can select only UDP. So depending on your intention, you choose what to select, or you leave it blank so you can capture everything. So I think I will leave it blank and then capture all interfaces are selected. Yeah. So I will just, once you've highlighted the interface you want to capture on, then you click on start and it will start capturing. Okay. So now I'm capturing. Nothing is going on yet. Let me generate some traffic. Okay. You can see things already going on. So as someone is using system, Wireshark will be running and capturing traffic. It captures live traffic, which you can save and analyze at a later date. Okay, so this is going on. I think my browser is open. Yeah. So let's say I've captured, I will just stop it. Then I can save, just go to file, then go to save as. This is it. You can see the ones I downloaded online and some that I've saved before. So you put the name, saving as Wireshark pickup ng. It always saves as .pcap. This P is packet capture ng. Okay. Now you can even, let me see. You can even compress it if it's too much, because sometimes traffic can be way too much. You can come. I don't know why this thing is not maximizing. Five. Hold on. Okay. You can, this is uncompressed because it's not much. But if it is much, you can compress it. Just click here. So when you click on save, when you click on this save, I've not put a name. I put a name, save will highlight. So If I click on save, it will save as a compressed folder, compressed file. I will need to, remove the compression to use it. You can also compress with LZ, but normally if the file is not much, just leave it uncompressed and then you save it. And that's all. So capturing traffic is really not difficult. Just select the interface, select filters if you need filters, and you capture. Are we there? Did we get this before we move to analysis?
Yes. So when you capture data, how do you interpret it? How do you analyze it?
Okay, that's the next stage.
Okay.
That's where he's going.
Okay.
Yeah, because when you are capturing, you remember we've used SS to identify services that are listening, services that are established. What is talking? Who is talking to who? Now, you want to now know what they're talking about. You use Wireshark and you capture the traffic. You can use TCP dump. You can use DarkStat. Okay, so you capture the traffic. Now you want to analyze. That's the next step. And I think we will practice with a file. We'll analyze a file. So we'll see how it's done. Okay. So I've stopped this one. Okay. So this is, like I said when we yesterday, this is blue team something. It's not attack. It's more like defense. And I used to learn defense with this organization. Where are they? Yeah. Sentry. So this is the website I use in learning defense. They basically teach blue team. It's a blue team network. So we'll be analyzing these packets, pick up one. We'll answer these questions. As we are analyzing it, I'll be teaching the commands as we are using it. Okay?
Sorry, what's the school? What's the learning this thing?
Blue team, they recently changed their name to elearning.sentry.org.
Okay, e-learning.
E-learning, yeah. elearning.sentry.org is basically a blue team website. It teaches you, this is a blue team level 2, this blue team level 1, blue team level 2. I'm just doing their free courses. It's actually a paid website, but they have a lot of great programs as free courses. Okay. So Wireshark, I learned Wireshark with this website. The Man of Thought introduced it, and then I did further studies on it with this website. So I'll just use it to teach it because this is just where I learned how to navigate it. Man of Thought didn't really go deep into Wireshark. He introduced it and then he left it. It's basically a blue team application, not red team. Are we on the same page?
Yes, go ahead, please.
Okay.
Yes.
So we'll be analyzing pickup one. Let me open it. So let's say you have a packet saved and you want to open it. You just go to File, Open. It's going to bring out whatever you saved it will be here. So you select the one you want to open. This is pickup one. And then you click on Open. Continue without saving. Okay. So this is it. This is what we'll be analyzing. Let me maximize it. File. Full screen. Yeah. So as you can see here, before we even start analyzing, let us look at what is actually going on here. So there's a lot of packets here. Okay, if I want to know the total number of all the packets here, I'll go to statistics. Then I'll go to protocol hierarchy. Tells me we have 9,515 packets. Okay, so it's much. Okay. Now,
sorry, I don't think it's the one we captured, everyone. This file you opened.
No, this is another one. It's not the one we captured. I don't have up to this number of traffic.
Yeah.
I'm just using this to teach how to use Wireshark.
It's okay.
Yeah.
Go ahead, sir.
So I have 9,515 packets here. Okay. Now, I'll move on. We'll just be answering these questions the way the website did it. So question 1, which protocol was used over point 3942? These are the kind of questions you answer in the field. So let's say someone is using port 3942 and you want to know the protocol. SS will tell you this anyway, but if you are using Wireshark, then this is how you find it, port 3942. You have to go to POS. So you just have to apply a filter that will show you port 3942. And it should be TCP.port, something like this. Yeah. So this one basically means TCP port 80 and UDP port 80. We already know that port 80 is for HTTP. But then the question says, so I can just edit this. These two strokes you are seeing means or, So either TCP or UDP. So I'll just edit this to 3942 and still edit this to 3942. Then I'll proceed. Now we have it. So we have, this is the protocol SSDP. So this SSDP used port 3942. If you want to see the port, you come down here. User datagram protocol, source port 3942, destination port 1900. What this means is this IP was sending packets to this IP. This one here, source, used this port 3942, while the destination, this one, used port 1900. Remember what we learned when we learned this. This is the packet that was captured. This is the packet details. This is the conversation, but it's encrypted, so you can't really read this. So this tells you a lot. This tells you about, if I select a frame now, let me select this one, 599. This is the frame, 2599. This is it. Packet, the packet is 136 bytes on wire. I can expand this. I will see more details. Details about these packets that I highlighted. So depending on what you are looking for, you have a lot of details here. Then when you come to Ethernet 2, this tells you about the connection. You still have some details here. Source, the source is Samsung. So basically it's a Samsung user. Samsung network was talking to another network. Now you have the type IPv4. You have Internet Protocol version. They're all here. You have destination address, which you can also see from here. If you want to see the ports, it's user datagram protocol, which will tell you the source ports, the destination ports, the length, the checksum, unverified. So they don't know the encryption that was used for this, and a whole lot of other things you can see with these two. So basically, we've been able to establish that this protocol was using this port, and it was this IP address that was talking to this one. Are we clear on this? Are we clear on this, guys?
Yes.
Okay. Second question. This is what you should take note of in this first one that we've answered. How did we filter out this port? So this is the command. Okay, tcp.port. When you want to use port as filter, you have to specify the service that is using the port. So either tcp.port or udp.port. So it will highlight all of them. Now, when you come to this filter, you see a lot of things. Okay, if I want to see only TCP traffic, I will just select only TCP, and then it will just display here. Okay, so that is basically it. As we are progressing, we'll be seeing so many filters and how to apply them. Now to the second question. Let's see. Yeah. Central. What is the IP address of the host that was pinged twice? Now, when someone is pinging, just like the way we do when we ping an IP address, what the protocol that actually carries out that command is ICMP protocol. If you remember, we learned it with one of thought. Now, you have to filter this conversation to show you only ICMP. Okay. You have to filter to show only ICMP. How do you do that? This is TCP. ICMP. Remember, ICMP protocol is used for pinging. Internet Control Message Protocol. That's the full name. Yeah. So how do we apply it as a port? And just type ICMP. That is it. This is it right there. Okay. Okay. So we have it. Now let's look at this information. This IP pinged this one, but got no response. Destination unreachable, port unreachable. This is why Wireshark is an interesting tool, because it tells you a lot. So this is an unsuccessful ping. It's pinged it again. You know, I didn't set time. Assuming the time is accurate, you even see the time when this guy pinged this guy. So he repeated the action again, almost same time, still unreachable. Then this guy pinged this guy, echo, ping, request. And when you see packet sent, this is packet sent, and it was returned, packet returned, packet returned. So this guy pinged this guy twice successfully. Are we getting it?
Yes.
Yeah. This is an unsuccessful ping. So it's not this one. This is a successful ping. You can see ping request. And this IP that was pinged in the next line replied.
Mhm.
So this two is one successful ping.
Yeah.
Then he pinged again and he replied. So another successful ping. So this is it. Now, what was the question? What is the IP address of the host that was pinged twice? Who was pinged twice? 8.8.4.4 was pinged twice, here and here. Ping request is what you look at, not the reply. Okay, request. Who was pinged twice? This guy, 8.8.4.4. Did we get it?
Yes.
Yeah. So
Yes, yeah.
if anybody pinged, it will appear here because pinging is ICMP protocol. You can see it under protocol. All these protocol are ICMP because I used ICMP as a filter. Now let's move on to the next one. How many DNS query packets were captured? Now we're talking about DNS protocol. DNS protocol is port 53, and it's not the entire DNS, it's query response. You know how DNS works. I think Nana already introduced it. You are trying to resolve an IP address. That's when you use DNS. You are asking like a public record who has this name, which number is using this name. Now they will respond. They will tell you, for example, www.google.com belongs to 1.9.9 ahead, that kind of thing. That response is what we are looking at. Query response, not the way the query itself. Are you guys getting it? Because this question can be how many DNS query packets were captured. It's different from query response. Okay, let me just pull it up so we'll see. DNS is protocol 53. I'll remove this one. Then I'll go to DNS. So these are all the DNS. Now you will see standard query. Then you will see standard query response. So this is what we are looking at. So even if you follow this information here, this guy, this IP, reached out to this one for a query, a DNS query, and then this one replied. So this is most likely a server. Why this is a client? If you remember what servers are and what clients are. Okay. So replied. What is the reply? No such name. See, so this is an unsuccessful. No such name. You can see another one, standard query response. Another, okay, it's not just one, because this is how DNS works. It won't just give you one reply. It's going to check all the records and then give you a reply. This is the query. This query got this reply, this reply, this reply, this reply, and this reply. You can see it's the same IP answering the same user. Now, this one, the first one was no record. Are we there? Oh, I think I've messed it up. I have to go back. Yeah. Okay. Did you guys get what I was saying?
Yes, Namdi.
All right. When you make a query, this is another query, you will get a lot of response depending on what information the DNS record was able to find. That's why when you see one request, this is a DNS request to this IP, this is a server. The server will give you so many responses depending on what your question was. So this guy is asking for the IP address of Yahoo, the DNS record, sorry, and these are all the response he got. The C name, the A record, C name. Wireshark captured all of them. Are you guys there?
Yes, now.
Yes. Yeah.
All right. So the question was, we should check the total number of how many DNS query response packets were captured. Simple. You just have to come here, you pick this, and you apply it as a filter. Apply selected. No. Just highlighted only that one. Okay. You can do DNS dot flags. We are looking for response. This is it. Dot response. Then this successful response equals to 1. Enter. Yeah. So these are all the successful response that came in. Just this filter gives you all of them. You can change this to 0. This should be request. This should be the request. Request is 0, while response is 1. Yeah. So this is everything. Now, if you want to know the total number, it's not this one, because you might see frame 929 and you think that all the packets here are 929. This simply means that we are highlighting this particular packet. Right? If I click on this, it will change to 988. So it's not this. If you want to know the total number, you go to statistics. Then you look at protocol hierarchy again. There are 19 number. Are you guys there?
Yeah, so
this is how you analyze packet capture in the field. Okay, depending on what information you are looking for. Okay, so that is just it. Let's move on to the. It's going to get a bit more technical as we are progression. What is the IP address of the host which sent the most number of bytes? MOT taught us this one, if you remember, how to know who is communicating more, who is using more data. So you just go to statistics. Let's see.
Where is Namdi?
The network there.
I think you get out of the line. Right.
here is network issue.
Run away scope. Where is promise? Hey, all our lecturers. This country, do you know that today I went to buy another internet? MTN 5G ODU. They mess my life. I go buy Airtel 5G ODU. They say they will come and install tomorrow or next tomorrow. In fact, I'm tired. What are you doing?
Good, good evening. Though. Sorry, I actually joined a bit late, but I know this thing. I'm actually using my phone to hotspot my this thing. So each time I check the IP, especially Metasploitable and Harley, although it somehow matches, but it's not always 1 9 something or be 192. Sometimes it will show 2 0 something, sometimes 10 point something. Is it because of the phone, or or is there any other this thing? I've not really tried it with external network, Sha.
Try external network.
Okay. Thanks.
Your own problem, no be problem. Sabiodun, what are we going to do?
So, Steven, let's wait. Maybe we're still going to wait. I want to believe it's the network. They're battling with the network over there, wherever they are. And we've taken 2 classes now, like almost halfway. You understand? Promise is there. Namdi is also there too. You understand? And we need to at least conclude one before we even say we want to start another one. What do you think? Others, please speak.
You're right. I don't understand this country.
It's so frustrating. Very frustrating.
Maybe high supremacy want to continue from where Namdi stopped. You dey laugh, Abi.
It's like it's back.
Sorry, guys. I was talking to myself. I didn't know I've been disconnected. Right.
Yeah.
All right. At what point did you guys stop hearing me? Let me know. Let me do a quick recap.
The last question. We have not answered the last question. How many packages or what?
Oh, since then, I didn't even
Yes.
realize that I was no longer, in the chat. Okay. So who transferred the most bytes, right? That's where we are.
Yes.
Okay. So I'll just get back to it. I think I mistakenly clicked on this X and it closed to something. So let me just get back to it. Yeah. So now to know that, you just go to IPv4. So you see, hold on, close this. Yeah. So you see addresses. Now each of these address sends this number of packets, and this is the size of everything. Now the ones they sent is under this column. This one sent nothing. If you just click this, it will rearrange this either descending or ascending. Okay. Now this is transferred bytes, the size, received packets, received bytes. We are looking for the one that sends the most, so it should be here. We arrange it depending on the highest one. Is this one? This is the highest one, 2 MB. So this is the IP. This IP transferred 2,903 packets, totaling 2 megabytes. Transferred 1,409 and received 1,583. If you add these two, it will give you this. Okay, so the ones this IP transferred, the ones this IP received, their size is here. So if you want to know the one that transferred the most, is this IP. If you want to know the one that received the most, is not the same IP, because what this IP received is just 207 kilobytes. So you have to go to the highest one. Just click on this, so it will arrange it. The highest one on top. Nope. Yeah, 4 MB. So this IP received the most number of bytes. That means this guy a lot of people were talking to this person, while this other IP was talking to a lot of people. This one was sending a lot of bytes, while this one was receiving a lot of bytes. They were probably talking to each other. Are you guys there?
Yes, so Namji. So please,
All right.
how do we get this information from statistics?
Yes. Okay. Let me just do it again. you go to statistics. If you want to see information about communication, you go to statistics, you go to endpoints.
Okay.
If you click on this, it will show you the network, the Ethernet, the network connections. This shows you IPv4 addresses. This shows you IPv6 addresses. This shows you TCP communication. This shows you UDP communication. So we were focusing on this one. Let me even use this opportunity to introduce these other ones. When you go to statistics, you will still see conversations. Okay, so you can still look at it from conversations, IPv4 conversations, but this one will not tell you. It will tell you B to A to B. So this IP to this IP, look at address A. These are conversation now. Let's say we want to check what those two people were actually. This was the IP we saw that they were talking to themselves, I think, or this one, I think. So if you want to see how many packets did A, this is A, this is B. How many packets did A send to B? 2 MB. How many packets did B send to A? This is where you get it. There are conversations, under conversations, under statistics. Are you guys there?
Yes.
So all these are there to help you navigate. If you don't know anyone, you can just simply ask AI, how do I get so from Wireshark? It will tell you what to. It will tell you the particular filter to use. Okay, I do that a lot. Okay, let's move on to the next one. What's the next question then? Which IP? We've answered this one. So pick up 2. What is the web admin password? I'll have to open packet capture 2. File, open packet capture 2. All right. So we are looking for a password. This question means somebody. Let's look at the question. What is the web admin password? A web admin logged into somewhere and used a password. Wireshark will capture it. That's why Wireshark is very powerful. To capture your password, okay, if it has access to capture your traffic, it will capture everything, including the files you send, everything. So we're going to find web admin, and we're going to find web admin's password. Now, web admin is most likely the username. So we're going to use search, find packets, yeah. And this, you can still apply more details when you are searching for something. This is, you can search by packet list if you know the packet number. You can search by packet details. You can search by packet bytes. So we'll be using packet details because what we are looking for is information somebody typed in. So it will be in these details here that we cannot read. This one is probably HTTPS, is encrypted, so we cannot read it. But I'm guessing web admin used HTTP. It's not encrypted, and we will be able to see the username and the password. So packet details, is it a string? Is it hex value? These are hex values, not hex value. Display filter, either a string or regular expression. Now we'll type web admin. Web admin. Now I can highlight this to make it case sensitive. I'll just leave it. Okay, because it's not, I'm not using the case sensitive distance. If you look at this question here, the web admin has capital letter A. So assuming I wrote it exactly like this, then I can do case sensitive, but I didn't. So I'll just leave it like that. Then I will search. Then I'll search. So we have the first result. This thing means that this particular packet has inside it, there is a web admin. So if I want to view it and see what this packet actually is, I will just go to follow. Is it? Let me see the type of conversation it is. HTTP conversation. Okay. I'll just follow the HTTP stream. Yeah. Now, this is, anytime you see red is the user, while blue is the server. Red is the client or user, while blue is the server. So this person was talking to this server. Now, what was the instruction? Get index.html, HTTP service. This guy tried to get, a user tried to get index.html from a server. Now, This is the host, the IP address of the user. Let me move this to the side. Look at this IP. This is the IP source of this packet. The destination is the IP of the server. This one right here. Let me still move it. So even if you look at this, it's the same network. This is the network address. So this is the server's address. This person is a user on this network talking to this server to get index.html. Are we there?
Yes.
Yes.
Okay. So Wireshark tells you all this. Now, when he, this thing means someone using the internet probably just clicked on a button with index on it. If you remember APIs and how they work, we already discussed that. When you click on a button, let's say you click on index or you click on home, assuming it was home that the person clicked on, you will see get/home. That's how the computer will interpret it. Now the server will respond HTTP 1.1 200 OK, which means this index.html exists. If it does not exist, you will see either 404 not found, that kind of thing. It will not be 200 OK. Now, this is the date of this conversation and even the time. The server, okay, server details is running Apache. This is the version number. It's a Debian server. This is the operating system of this server. It was last modified. So see all this information now. I don't need to go through all of them one by one. So this is now the index document type HTML public. You can see the body of the index. And this one is web design. If you know web design, you understand this. I don't even fully understand it, but it has to do with both the background, the color, and everything. This will not be how it will appear to this user. When API carries this and drops on the user's application, the user will now see index written in the normal index format. But this one is what you see on the back end. So this information is not the one we are looking for, because this guy did not enter any username or no username was entered, no password was entered. Let me scroll to the top. Yeah, he just clicked on the index button, that's all, and the server replied. There is no other red to show where the person typed username, so it's not this one. Are you guys there?
Yes.
Yes.
All right.
Yes.
All right. So this is the first result we got with find. I will just move on to the next one. I will just remove this and click on find again to take us to another one. Is it the same one? Let's see. We follow this conversation, another HTTP conversation. Yeah, this is another one. Okay, this is what we are looking for. Exactly. Web admin password, SBT123. So this user typed in password and clicked enter. So it took password.txt and the server saw it. Now we are interpreting the server, what the server saw. The server saw web admin password, SBT123. And Wireshark captured it. Are you guys there?
Yes.
Hello, are you guys there? All right,
I know.
all right. So with this now, you can see the web admin password. You don't even need. That's why if you have access to a server, if you break into a server, you can get everybody's password. You don't even need to use social engineering or anything, because once someone types in a password and clicks on enter, server will receive it, and anyone that has access to a server will see it by just capturing the traffic, including information about the person. This is what this information is what is called cookie. Yeah, it tells you about the client, the IP address, the type of machine they are using, or blah blah blah. Yeah. So even the server will save this information, so it will always remember this user. So if you have access to a server, there's a lot you can do. That's why servers are always protected behind firewalls, behind cloud. You can't just access a server just like that.
Is that
Except
mostly for the port 80 bar?
for what?
Is that just
Yeah,
for
this
the port
conversation.
80?
Yeah, this conversation that we analyze is port 80. That's why you are not advised to use port. You see, it's HTTP. HTTP is port 80. Assuming this was HTTPS, this will be encrypted. We will not be able to see this. Do you get it? let me look for HTTPS and open so you see what I mean. I'll close this now. I'll go to HTTPS. HTTPS. Nope. Hold on.
Four, 443.
443, yeah. TCP.ports. Ports equals to 443. Okay, these are HTTPS communications, TCP. Let's open it and see. You will see it that it will be encrypted. Follow TCP stream. Nothing. No, it shouldn't be nothing. Hold on, let me see. Let me open this one. Follow TCP stream. Nothing again. Entire conversation, 0 bytes. Oh, these people didn't exchange any information. How do I view? Let me see. Let me check for UDP. UDP dot ports. Nothing. Okay. So that means there is no HTTPS conversation here, but there should be conversations that are encrypted. Let me see. Nothing. Okay. But basically, if it is a HTTPS conversation and you follow it to view it, you will just see jargon that you cannot read because it is encrypted. But when it's not encrypted, you can just literally, it will just be English and you can read it. Okay. This particular packet does not have HTTPS conversation that we can open. Maybe I'll have to open another conversation and see. This thing should just get out from here. Okay. ARP, TCP. Oh no, I should be able to view one of these. Nothing. Okay, maybe as we are progressing, I'll just, maybe before we finish the class, if I see anyone, I can just change to another packet and check for HTTP and see what it looks like when you open it. Let's run through all these questions. Where is it? Here. Okay. What is the version number of the attacker's FTP server? This is a bit tricky. Are you guys there?
Yes, sir.
yes,
We are here. Yeah,
Okay.
we are here.
So this means someone entered into this server, an FTP server. An attacker entered into an FTP server. So we'll look at this server. The server must have captured this attacker's information. And then we'll see the version number of the server. We already saw how to do it. Once you open the conversation by following it, you will be able to see the version number of the server. Okay. Let's see. Now, how to know version number FTP server? What about name, password? Okay. Let me come here. I'll remove this. Let's see. Let me see about name, password, anonymous. I will still use find. I will still find web admin. I want to follow conversations and see if I will find an attacker. This person basically just got indexed, not this one. Find the next one. Follow HTTP string. This person type password. Somebody must have stolen this password and then used it. So I will still find another one on this one. Just follow this one. This is the first one we opened. Not this one. Find the next one. Okay, see what will happen. Let me search with the password itself. I will search with SBT123. So find. Yeah. Fine. Sure. Where did this attacker use this password? Oh, I just saw something interesting. Look at this get password. Somebody downloaded password. Let me follow this. Oh, guys, this is something interesting. Now, this is the attacker. Now, ordinarily, if you are inputting your password, it will be post password.txt. But this is get. So an attacker got this password.txt from this server. I was just going round and round looking for it. You guys get it now?
Yeah, because if there is any kind of filling form or if you need to put in something, it's supposed to be like
form and
post
put password. It should be post. Yes, it should be the flag. The method. This is called a HTTP method. The method should be post password. But now this person was getting password from this server. That means this person is an attacker because you don't have any business getting a password except if you are stealing it. Are you guys there?
Yeah.
I was actually looking for where the password was used. I didn't see. But this one that we already opened is actually a get. And now, if you look at the server, this is the server information. Apache 2.4, 2.4.3.8 Debian. That's what we are looking for. Are you guys there?
Yes.
Let me see. Let me go to the last conversation.
Yes, man.
Conversation filter. I want to see something. I want to see what actually happened here. Okay. I'm sorry, guys. It's been a long time I did this, so I can't actually remember everything. I'm just trying to filter some things, see the actual conversation that went on between this person and this server. So sync, acknowledge. This is that TCP handshake that we talked about. Now, this is acknowledge, then you got the password, and the password was sent as a plain text, and then he finished the section, acknowledge, yeah. So this person just logged in and got this password and then ended the session, or he must have used it to attack. So this is what we're going to do. If we want to see what he did, we will follow his IP. We'll follow his IP. This is his IP. So I will just apply his IP as a filter. This guy is being smart. Yeah. Okay. This is where he got password. Yes. What did he now do after getting the password? So many things. I did so many things with transmission. Response. Transfer complete. This is interesting. He must have transferred something. So let's follow this. And this is FTP. Probably used the backdoor. So let's follow it. Yeah, this is what I was looking for. So guys, this is how you do investigation. Oh. This is how you do investigation. This is server information 220 blah blah blah. User anonymous. Remember, this is a user. He logged in with anonymous. This is like user, you input your name, anonymous. Then the server responded 331, username okay, send password. He now entered this password. Now 230 login, server responded, login successful, type 1. Now the attacker opened these ports, all these ports 192, 168, 56, 103, 1932. Now server responded okay, active data connection established. Retrieve malware.exe. Data connection already open, transfer starting, quit. So this guy logged into this server and downloaded, retrieved this. This is a malware file. Are you guys there? I know it's somehow, but this is basically how you do investigation. This is basically how you do investigation, okay? It might get confusing, but as you are scrolling, normally when you capture packets, you will scroll through. Once you scroll through, you'll be seeing interesting things. Even if you, okay, we look at this conversation that we followed to come here. This guy, let me go to the top. This guy, sync, he sent a sync with this IP. He sent a sync. Now, this one responded, sync acknowledge, this is the TCP handshake. Now, the server responded, this is the server IP, this is the user IP. Response, ready. Requested for username, he entered username. Server responded, username okay, send password. He entered password. Then login successful. Transmission. That's just basically what we just saw by following the conversation. And then he retrieved this malware and then transfer complete, and then he ended the session. So it's not going, this will not be the end of it. We will still see where the person used this malware. Are you guys there? We are basically doing traffic analysis. Yeah, we've captured, we're analyzing, and as we're analyzing, we're investigating. Okay. So let's answer some questions. Which port was used to gain access? No. We. Web admin password, we've answered it. What is the version of the attacker's FTP server? Version, I think we've answered this already. The attacker's FTP server. Where the attacker got the malware is this one. Hold on. Yeah, retrieve malware. So we'll just follow this. Follow the TCP string. This is the attacker's server. The attacker logged into his own server and then downloaded this malware, probably to use it somewhere else. Okay. Let's see. Let's see who started the conversation. Sync. Yeah, this IP. This is the attacker's IP. This is the server. If you see that on the same network, so it's probably his server. He's a user 103. This guy is .1, meaning is the server's address. He logged into, established connection with his server, retrieved, logged in with, the attacker's username is anonymous. The attacker's password is IE user@IE Win 7. Okay. Now he retrieved a malware, probably used it somewhere. So we still follow his IP. Let's just follow the IP. I will use it as a filter, apply as filter, selected.
Are you sure you retrieve a malware or you apply a malware?
No, that one we were on. Let me open it again. I'll just follow this TCP. See what happened. This is a server saying I'm ready. Put your username. This line is the details of this server. And this server belongs to this IP address. Look at where the conversation started. Sync. sync, acknowledge, acknowledge. This is TCP handshake. That's why I said this thing is cumulative. You have to understand one to move to the other one. These 3 lines is the TCP handshake. This user reached out to this server and sent a synchronization request. The server, this is the IP of the server. Look at it here on the next line. Responded to this user and said, synchronized, acknowledged. This is like saying, hi, are you there? Yes, I'm here. Who is speaking? It is me, the user. This is the user saying, it is me, the user, to this server. Are you following it? Are we guys there?
Yes.
All right. Now we still follow the conversation. Now this server, just you know that this is the server's IP. This is the user's IP. Now this server said TCP window updates, blah, 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 blah. This is just still acknowledging. Now the server still said, response, I am ready, with his banner. This thing is called banner. Banner basically displays information about the server. The version number. This is the number we were looking for, 1.5.5. Now, this user the server requested for password. The user now inputted password. This is FTP. Remember, at this point, he has already established TCP handshake. Now he has moved to FTP. So he used FTP service to retrieve this file.
Yeah, what I'm actually saying is that that's where he applied the malware. He applied the malware to retrieve.
No, we've not gotten to where he applied it.
Files.
No. It's just like you know, if you're an attacker, you already have malware you normally use. So it's just assumed that he saved this malware on his server. So he went to his server and he got it. He has not used it yet. We will still see where he used it. It's just like you now saving a file you saved a malware.exe in a file on your system. If you want to use it, you just go to that file in your system and download it. But he saved on a server, so he just retrieved it from the server. He has not used it yet. This is what this conversation is saying. He logged into his server with this username and this password, and then he retrieved this file. Resisting, not scrolling. He retrieved, see, look at it now. Retrieve request, malware.exe. He retrieved this file. Then he ended the session, transfer complete. Once the data sent it, look at the server telling him, I've already sent it, transfer complete. He ended the session, quit. Goodbye. Finish, acknowledge, and he finished it. So he has not yet used it. It's just like how you have if you have your picture saved in cloud, then you go to cloud and you download it. You've not yet used it.
But why will he download request for a malware on a server? Will
you get it
on a server?
Let me put it this way. Let's say I am the attacker, and Steven, you are the person I want to attack. Okay. Now, the malware I want to send to you, I'm not going to have it on my system because it might misbehave and spoil some things for me. I have a number of malware that I'm using. I have them saved somewhere else on a server that I'm on the same network with. Okay?
It's his own server. His
own server. Yeah. Look at the IP. The IP, they are basically on the same subnet.
On the same
network. They are on the same subnet. Look at it. Yeah. Look at it.
Yes.
So he went to his own server and got a malware that he intends to use. He hasn't used it yet. Are you following it now?
Yes.
This malware is not on his system. He got it from a server. Now, as he has downloaded it, let's follow the conversation, because this is how Wireshark analyzes things. It's just one conversation after another, not everything together. Follow TCP stream. He got in, logged in to his server with this password, login successful, open ports, got this malware, and then ended the session. That's all. This conversation did not show where he used it.
So this is on the server he's trying to attack.
On his own server. No.
On his own server.
His own server. Look at the IP. The IP is basically the same thing. They're on the same subnet. Look at the IP 192.168.56.1. This is his server. Look at his own 192.168. This is even a private address.
Okay,
Just like your own is 192, yeah. Just like your own is 192.168.1 point something. If you check your router, if you're using a router, your router will have this address, this exact same address. But your device, your computer will have another one like this one.
Yes.
So in his own case now, he went to his own machine and got a malware that he intends to use somewhere else. We've not seen where he used it. Are you guys there? I like as this session is interactive.
Very well. Very well.
Are we on the same page now?
Yes. Go ahead.
God, we are doing investigation. Let's say someone attacked a company and they call you. And they present to you packets that they captured. This is how you analyze it. Now we've been able to establish who the IP address of this attacker. Look at it here. But we don't know the identity yet. But this is a private IP, so we can't resolve it except if we are in their. Let's say this subnet belongs to a bank. This is the bank's server, and one of their workers used the system to do this. Once we identify this, we'll be able to identify the particular system. Whoever owns that system has questions to answer. You guys get it?
Yeah.
You're right.
It might not be the person that did it, though, but his system was used.
It was used.
Now, when we get that person's system, we will now check. We'll now use SS and check. Do you have SSH running? If the person has SSH running, it is possible that someone else logged into his system with SSH and used it. If SSH is not running, that means it's that particular system that was used. We now start asking him, who accessed your system between so and so time? We still get the time from Wireshark here. Between so and so time, who used this system? You retrieve the file. Are you seeing the investigation now? But then you have to capture the traffic to actually know. So if they have an IT department will be capturing traffic on the server, and even the users will not know. So if something happens, they will be able to answer. Okay, are we on the same page?
Yes, right on.
I want us to be on the same page before we proceed. All right, I'm seeing thumbs up. All right. So on to the next. This is blue team anyway. It's not what we are focusing on now. You're supposed to know red team attack. Everything about attack before you now enter defense. That's why we are asking all these questions. If you understand how attackers work, it will make sense to you. So you now see how defenders catch them. All right. So the next question, we've seen the version number of that's why this question is, what is the version number of the attacker's FTP server? You see how the question was coined? Meaning, this is the attacker's server and this FTP service that he used to access this server and get this malware. That means the information we were looking for is this. This is the information we're looking for, 1.5.5. Belongs to the server of the attacker, not that other. That other web admin is just another user on another system with a different IP. That person just logged in, retrieved index file, and logged out. No, that's not an attacker. Do you get it? Are we there?
Yes, Nnamdi.
Okay. So let's move to the next one. Now we'll look at where is it? We'll look at which port was used to gain access to the victim's Windows host. Now it's getting interesting. This attacker used this malware.txt on someone that is using a Windows machine. So now we need to know the port he used to enter this victim's Windows host. You guys understand the question? You understand the question, guys?
Yes, now. Yes.
Okay. So we will have to follow, instead of just randomly looking at all these packets, we'll just follow this guy's IP. We already know the IP, except if he changed system. Maybe the person is tricky and change system, IP will change. But if he continue to use this IP, we'll just follow it. We'll apply it as a filter. Selected. Okay. So this is everything that this IP did. So after getting where, yeah, this is where he logged in. This is where he got the malware. Where did he use his quit? Push attack, finish, acknowledge. Let's see. Let me follow this last one. Okay. CD desktop. This is it. Now look at this is Microsoft Windows. This guy logged into a Windows. You know, remember blue is server and red is user. Remember? Okay. In fact, let's follow this entire conversation. Let's filter it. Conversation filter, TCP conversation filter. Okay. Let's see what happened here. What happened here? No. This is not it. Let me use follow. Follow TCP string. Okay. Okay. Now let's look at the information we have here. We have a Windows server. These are the details of the Windows server. This is the version number. Now, this guy logged in with user, IE user, and typed CD desktop. Now CD desktop opened. He now types dir. You know, Windows, just like we do ls in Linux, in Kali. If you are using Windows, you will type dir. It's just to show you the directory. This thing is equal to Linux machine. Assuming this was Kali Linux, he will be typing ls. But in Windows does not understand ls. What he understands is dir. So he typed dir and it opened. Okay. And this is the directory on the home. He was on home. You can see it here, directory. Users, okay, he was on desktop. And these are the files that are on the desktop. So he opened this desktop. Now, what else did he do? User anonymous, pass anonymous. Okay, he logged in as an anonymous user. Okay. Echo gets malware. Echo, he planted this malware here. Okay, he planted the malware and yeah, with FTP. What else? Anonymous login succeeded. Binary gets malware. Bye. See, he planted the malware and exited. Are you guys there? Do you see it?
Yes.
Do you see it? Let's even check. Let's even check what. Look at all these things here. This is when he got in. These files were on the desktop. Then where did he plant the malware? Here. He planted the malware here. That means we will see the malware. We should be able to see it. Okay, he used directly again. And then malware, look at the malware. Malware.exe. Look at it. He actually planted it 4:14 p.m. on 2nd 8 2020. If you check before and after, you will not see this malware. Let's go up. 4:14 on the second. On the second, nothing, no malware. If you go through all the files here, there is no malware. Look at M. Okay, no malware. But after he planted it, this guy is funny. After planting it, he even checked if the thing was successful. He still did dir again. Dir again. He listed the files there, and he confirmed that the malware was successfully planted on the Windows machine now. Now, what else? Did he use it? No, he left. So he just planted malware and he exited. Did you guys see it?
Yes.
Yeah. So this can we even tell you the exact time, the exact date, and the exact time he planted the malware. Look at it. This is the date, this is the time. So whatever this malware was designed to do, the malware will now do it. This is the threat that we are looking for. And we know who planted it. And we know when the person planted it because Wireshark captured it. All right, let's finish answering the questions. Which port was used to gain access to the victim's Windows host? Which port did he use? We will find out. We just need to highlight his communication with this Windows host. Okay. Attacker was using this IP. This is the Windows host. The Windows host is even a server because it's 56.1. So he planted this thing on a server. Now we go to, remember where we go to view ports. Transmission protocol. This is it. Source port. This is his own port. This is the port he used to gain access. Destination port 50.50493. So this port was probably open and was listening. So this is his own port. This is the destination port. So this is the IP of the destination. This is the port of the destination. This is the IP of the attacker. This is the port of the attacker. Are you guys there?
Yes, so
All right. All right. Next question. Next question. What is the name of a confidential file on the Windows host? He did DIR, so we just check the DIR that he did. We don't even need to get on this Windows host. We just follow what the attacker did, and we follow the conversation TCP stream, and we look at this directly. Confidential file that is here. Look at it. Employee information confidential.txt. So assuming this guy wanted to tamper with the employee information, maybe get their phone numbers, house address for social networking, you just download this file. He will just do get employee information confidential and he will get it. Did he do that? Is this file still here? Did he delete it? Okay, it's still here. He did not delete it. Assuming he deleted it, we will not see it here again. He exited. No, he didn't get it. But we were able to see, following what the attacker did, that there is a confidential file on this Windows server. They even have, this server even has SSH on. It has FTP daemon on. It has log file. So this file, this is another interesting file. This file will contain the login information of all the employees that use this server. This file now, if you download this file and open it, you will see their usernames and their passwords, log file, and it's not even encrypted. Are you guys there?
yes, sir.
This is basically how investigation is done. But these days, it will not be this easy because it will be encrypted. Except the people, except the company, they don't have an IT department. Any IT department will tell you you have to encrypt everything. Okay, with very strong encryption algorithm. All right, which other information? We've answered this one. What is the name of the log file that was created at 4:51 a.m. on the Windows host? Okay, a file was created by 4:51 a.m. Still the same thing. We just follow the conversation 4:51 a.m. Which one was created? Look at it. Oh, the log file. The log file was created by 4:51 a.m. So this is the answer to that question. I think that's the last one. Yeah. I already passed the quiz. I already answered everything. There are still other ones, Sha. There are still other ones. This is just one that I did when I was here. When I was practicing this thing, I was able to analyze a lot of packets. If you come here, you see a lot of packets that I've analyzed. So this is just, you just practice. There are so many things you can do with this. Okay, on to question. Does anyone have any question?
Yeah, it's not basically about the Wireshark, it's about what you're using. How can I get something like this?
You install it. We've all installed it now. Just
No,
run
I
sudo.
the Wireshark, this where you get your questions from.
Okay, I got it from this website. I can paste it on the group.
Did you pay for it?
I got it from this. No, this is a free course. You can see it's a free course. There are paid courses anyway,
Okay,
but this is
thank
a free
you
course.
very much.
Analysis with Wireshark.
You just paste it, please. Thank you.
I'll
very
paste
much.
it on the group. Let me just copy it now and paste on the group. I don't know. It might not bring you here because this is my account with my name on it. So you will have to create, when you get in, go to home, then create your account, then navigate to free courses. Then you go to let me get the name of this course. You go to cyber introduction, introduction to something. See this one, visual machines. No, there's so many courses here, so just choose the one. Dark web operations, no. Vulnerability management, no. Just some of them are here. Introduction to network analysis. This is it. So you click on this one. I think I'll just click on this one. This one is a free course. Yeah. So let me just paste this link.
But is it mainly for blue team alone?
Yeah, it's for blue team. Yeah, an attacker doesn't really need this now. Your own is to attack.
I'm just asking if they
Let's
have the one
see.
if they have the
Where
one
is our
for the red team also.
red team? Red team, yeah. The tools we are learning with MOT is for red team. Red team is just attackers, while blue team is defenders. Not seeing our group here.
I understand. I mean, if there's a site where you can still practice these questions on the red team.
Okay. I don't know. I'm not using any site for red team. I'm not using any site for red team. Okay. I was already learning blue team before I discovered Man of Thought. And then he said to be good with blue team, you have to know red team. So I've not been doing this for some time. That's why I was, having difficulty remembering stuff. I was doing it as at the time we started the red team, I was doing this, but I've not been here for some time. Okay. So, but you can do it if you intend to work as a SOC analyst, then you have to do it. If you intend to analyze traffic, learn how to analyze traffic, then you have to do it. But if your intention is just to be attacking, you don't necessarily need it. Okay. Scope here.
I do.
Okay. Reason why I asked, when I was doing this thing, but we used to talk that time, and I think you are doing it too.
Yeah. Also,
Yeah, come to talk when I teach.
yeah.
Okay, but no, just to let you guys know that
I know our lecturer now.
it's good. It's a good skill to learn. Okay, just learn it. Learn how to use it. You never can tell. You might have need for it. And I think if a company employs you as an attacker, they might still require you to do defense work. So it's good to know both. Know how to attack. Know how to defend. You even get more work as a defender than as an attacker. Okay. And do we still have time? 11. TCP dump is still Wireshark. It's just like mmap and zemmap. TCP dump is using command line to do all these things. Is a little bit more complicated. But if you know how to use Wireshark very well, you don't necessarily need TCP dump. They are the same thing. Then dark stats is basically used for network statistics. If you want to know what is using the most traffic, same thing you can still do with Wireshark. That's why I said all these tools are related. Same thing you can do with Wireshark. Who is speaking more? Who is using the most traffic? Who is using which port? That's what Darkstar tells you. MOT mentioned it when he was teaching us disruption of service. Okay, so I just picked it and I checked it up. It's used for analyzing traffic. It just shows you statistics. It's basically Wireshark statistics. That's what it shows you. So if you know Wireshark and you know it very well, you might not need TCP dump and darkstat. Wireshark is like a tool that combines all of them, and it has GUI. So using it is easy to navigate through. It's already 11, so that's me summarizing. Except if anyone has any questions to ask. Okay. In the absence of any questions, I will hand over to Stephen.
Guys, please let's appreciate Nnamdi. Please. This is too much. Professor Nnamdi. Thank you very much. Really appreciate you. This is massive. We really appreciate this. And then, okay, come in. Thank you
So
so
I
much.
already mentioned this before, but if you are using this tool or any tool and you have difficulty, simply navigate to ChatGPT or Kimi or anyone you're using and ask. You will get the commands to use. Okay. If you get confused, just ask AI. AI will tell you what.
Yeah, thank you. I use kimi.com a lot. In fact, anytime I have problem like this, I take Kimi as like a friend. If I want to use kimi.com now, the first thing I will say, hi, how you doing today? Like I said, they talk to person. uh, Sometimes I will say, I hope you'll be able to assist me today. And then they see that thing there. I'm telling you, that AI. Do you know that this AI already understand my pattern? So when I asked, I was surprised when he was telling me you're on a path to cybersecurity. I said, sure, who tell you? It's because of the questions I've been asking. So that thing is should be our friend, sincerely speaking. Thank you everybody for attending this. I
Let
will
me let
share.
me add to what you just said, Stephen. The
Okay,
same thing you are doing, I also do it. But in addition to that, I use ChatGPT a lot, though I use Kimi too. I used to tell it to assess me based on what I've learned so far and direct me
imagine,
on the next step. And it will assess
imagine.
me and grade me and then tell me the next thing to learn. So there are so many things you can do with AI. Just know how to navigate it and how to use it. It will grade you. It will tell you where you are not so good. It will tell you where you need to polish your skills and the next thing to learn, and even tell you where to learn it. Okay, whether free or paid, it will tell you.
In fact, sincerely speaking. Nana Kwesi, I saw your advert too. Nana have started cybersecurity training in Ghana and is charging 500 CDs. I saw your post.
Yeah.
Saw your
More. Small.
so in case you need a partner, Namdi is here. He's a big lecturer. He will scatter them in Ghana
Yeah,
here.
yeah,
I'm here. Oh.
yeah.
Bring work, more job.
He's already my partner.
Aha!
He's my
That's the
partner
essence,
already.
the essence of this coming together. Relationship you never can say, and that's why we need to cooperate and do things. And I have this internal joy when I see us, growing together, learning together. There's this kind of internal joy that comes into me, and that thing will keep propelling me. I will never relent to, coordinate, advise, and just make sure everybody is progressing. Thank you, everybody. Thank you. Have a wonderful night rest and goodbye. I will share the recording to the group for those who are not able to make it. All right.